So, hello and welcome on today's lecture on design of Taguchi's experiment. As we all know, Taguchi's experiment are the basic foundation for conduction of engineering experiments with incorporation of Taguchi's philosophy for quality. So, as Taguchi said, the quality is about minimum deviation from the target value. So, Taguchi's experiment is the experiment which provides the results with minimum possible error, and it ensures that there is minimum effect of noise factors on your results of experiment. So let us proceed with this lecture. The agenda of today's lecture is basic principles of experiment, then DOE terminology, what are the various terms which we use in design of experiments, then Taguchi's methods, what are the steps in Taguchi experimentation, then orthogonal arrays, how to design the orthogonal array, significance of orthogonal array, and selection of orthogonal array for your experimentation related to your field of research. So what are the basic principles in experiment? Number one, replication, which basically means if we repeat the experimentation with same standard operating procedure, what is the consistency in result? So if we repeat the same experiment by same process two or three times, the results must be same. So that is called as replication. Now replications are intentionally incorporated in the experiment while data recording to ensure that our reading is not full of error, or our reading is not a kind of fluke. So by using the replications we ensure that whatever the readings we are getting are consistent. Then randomization, it is the concept which must be there in engineering experimentations, because when we are dealing with sample, then sample must be a representation of complete variability in the complete data set. So randomization is one of the best way by which we can ensure that maximum variability of the data set is covered in the sample. Number three principle is blocking. So blocking is while conducting the experimentation and while recording the data, we will try our best to block the noise factors from our sample. So as you can see in this picture, this is my sample. So I am creating a hypothetical, what I can say, a cover or a bubble, and I am ensuring that there will be no effect of these noise factor at least on my sample, because it is very much difficult to eradicate the noise factor, but yes, to some extent it is possible that we can prevent it to affect our sample. Then coming to DOE terminology, what are the various terms which we use prominently in design of experiments? So number one is factor. So this is the term which is used mostly in design of experiments. What is the factor? So factor is basically a variable or attribute which influences or is suspected of influencing the characteristic being investigated. In some other examples, we call it as measure of betterness. So whatever the research I am going to conduct, whatever the topic or whatever the main deliverable of my research is basically a measure of betterness. So any factor or any variable which is either influencing or it is suspected to influence the characteristic being investigated is called as factor. What can we call as a factor? Any variable which affects the output, as I said. Then a factor can be controllable or uncontrollable. It can be quantitative or qualitative. And factors are always independent variables. So it is about factor. Next term is levels of factor. Now, once the factors are decided, what will be the values of factor? So that values are represented in some or other numeric quantities. So if the factor is an attribute, level means state. So if there is a switch, it has two levels, one or two, that is on and off. If the factor is variable, then the complete range. First we will find out the envelope, then dividing that envelope into number of levels required. So basically any value which is getting computed, or it is a variable, we will divide that range into number of spans, and then let us suppose if we divide the complete range into 3, then we can represent the level of factor as low, medium, high. Then next is treatment. So one set of levels of all factor in a trial. So if I have 4 factors, the level of first factor is 1, level of second factor is 2, level of third factor is 3, and level of fourth factor is again 1. So this one set, one row of this particular table, or one row, one level of every factor. So if we have 4 factor, so 4 factor का सबका लेवल उस सेट को कहा जाएगा ट्रीटमेंट. फॉर एग्जांपल, experiment being conducted using temperature T1 and pressure P1 would be one treatment. Then for this next set, if temperature is T2, pressure is P2, or temperature is T2, pressure is remains P1, then it will be called as second treatment. Then experimental unit, we know what is experimental unit. It is the prime setup on which we conduct the experiment. So if your experiment is laboratory experiment, it will be some experimental setup or apparatus involving the person who is conducting the experiment, test piece, material, subject, etc. What is response? So it is the ultimate result or output obtained from the experiment. So it is a dependent variable. Then effect. Effect of the factor is change in response due to change in level of factor. So as we said, response is there, that is my output. If I change my input, that is factor, how much change is there in output, that change is called as effect. Then experimental error. So it is the residual value which is not the main effect as expected in experiment. So it may be due to uncontrollable factor. Simply means whatever the effect which was either anticipated or expected by changing the factor, if the change or the effect is more or less than that anticipated effect, that particular part which is more or less than anticipated, it is experimental error. Then coming to Taguchi methods. So it is the methods proposed by Dr. Genichi Taguchi, a Japanese scientist who contributed significantly to the field of quality engineering. Now, as per Dr. Taguchi, quality should be in the process to ensure it in the product. Now, traditionally, what we do, we always inspect the quality in product. But the main reason, or the main stakeholder of the presence of quality in the product is the process by which the product is manufactured. So Dr. Taguchi says that the quality should be in process. If it is in process, definitely it will be in the product which is manufactured by that process. So as per his philosophy, inspection is like a post-mortem. It cannot cure the disease. So the damage is done. Now you are just inspecting that whether it is done, and if it is done, how much it is done. So he advocated robust designs. Now robust designs, as I already said, it means that the experimental setup will ensure that there will be minimum error, and minimum effect of noise factor. Noise factor means the factor which disturbs the result of experiment. So Taguchi methods or techniques are about making use of orthogonal arrays for designing and analyzing the experiment. So you can note down this term, orthogonal arrays. So these are the specially designed arrays by Dr. Taguchi, by which we can design our experiment first, then we record the data from the experiment in these arrays, and then these arrays can be statistically analyzed for getting the required results. Now, what are the steps in experimentation, or basically the Taguchi experimentation? Number one is state the problem, then determine the objective, determine the response and its measurement, then identify factors influencing the performance characteristic, then separate the factors into control and noise factor. This is very important. Step number 5 is, if I have 10 factors, how many of them can be controlled? Let's say in laboratory, I can control the pressure, I can control the temperature of the system, but I cannot control the ambient temperature or vibration unless we use some air conditioned effect or something. But normally, in normal ambient condition, the ambient temperature and ambient pressure is not in our control. Then step number 6 is to determine the number of levels and their values for all factors. As I said, if the factor is measurable, first find the envelope, what is the maximum reading and what is the minimum reading. Maximum minus minimum will give you the envelope. So if the envelope is of, let's say, 9 units, you divide them into 2 or 3 as per your comfort. And if you divide it into 3, then that 3 spans will indicate the 3 numeric values 1, 2 and 3, which is basically the representation as low, medium and high level of that particular factor. Then identify the control factor that may interact. Now this is one more term which is there. Some factor may interact with each other. Okay, so if there are 7 factors selected, one thing is that these factors are affecting the output. Number one. So if I say job satisfaction and there are 7 factors, let's say salary, working hours, incentive, what are the holidays, what is age of the person, what is the gender of the person. So 7 factors are on the left hand side which are influencing the job satisfaction. But there is possibility that any 2 factor from these 7 factor may interact with each other. So salary and working hours may interact with each other. We are not sure. So such interaction should also be identified in your area of research. Then step number 8 is selecting the orthogonal array for experimentation that we will see. Then step number 9 is assign the factors and interaction to the columns of OA. OA is orthogonal array. So once we select the orthogonal array, the columns and rows are blank. That is the format. Now we have to assign the factors and interaction to the columns of OA. Then conduct the experiment, and conducting the experiment is basically followed by recording the data in orthogonal array. Then analyzing that data, interpretation of the results, then selecting the optimum levels of significant factor. Okay, so if I have 9 rows in my orthogonal array, what combination of factor will give me the best output or best outcome or best effect or best dependent factor, that I will find out. Then predict the expected results, and then, as we did it for a trial of experimentation, we have to run a confirmation experiment at last. Then coming to orthogonal arrays. So orthogonal arrays were mathematical invention recorded in early 1897 by Jacques Hadamard, a French mathematician. So the Hadamard matrices are identical mathematically to the Taguchi matrices. So it is basically the adaptation of Hadamard matrices, but Taguchi has used it for conducting the experimentation with some rows and columns rearranged. So what is the nomenclature of OA? So you can see here L suffix A in bracket B to the power C, where L is Latin square, A is number of rows in the matrix, B is number of levels, C is number of factors, that is number of column in the matrix. And how to calculate the degrees of freedom, that I will explain very shortly. Degrees of freedom associated with orthogonal array is A minus 1. So whatever the number of rows are there in particular matrix, minus 1 is the degree of freedom. That will clear it in some next slides. Now these are some of the sample of orthogonal array. So this is the basic structure of orthogonal array. You can see there are 7 columns and 8 readings, which means that there can be 7 factors which can be recorded in this matrix. And how many readings are required? So 8 number of readings are required. So this 8 represents the suffix here. So the matrix which is visible here, the orthogonal array which is visible here, is this type, that is L8, 2 to the power 7, where 7 is the maximum factors which can be incorporated for 2 levels. So as you can see the readings, all the readings are in the form of ones and twos, because this is the 2 level orthogonal array, where L8 indicates the 8 readings and 7 indicates the 7 factor. Now how to design the orthogonal array. So Taguchi suggested the use of orthogonal array for design of experiments. So one technique is there, that is linear graph, which simplifies the design of orthogonal array. These arrays are applied by engineers or scientists without acquiring advanced statistical knowledge. So if you cannot design the orthogonal array, then some standard arrays are available and you have to just select the array. So rather than designing it, we can select a perfect array which can match my requirements, and I can proceed with the conduction and analysis of experiment. So these orthogonal arrays are simple and easily adaptable. Lesser number of trials, that we'll see in the next slide, and it is best to study the main effect and applied in screening or pilot experiment. Now about this point, lesser number of trials, we can compare the orthogonal arrays with full factorial experimentation design. Now let me give one brief idea about full factorial design in this slide. So as compared to full factorial experiments, L to the power k readings are difficult to record. What is L to the power k? Let me give you a brief introduction. What is full factorial design? So L is the number of level and k is the number of factor. So let's say if there are multiple factors involved in your study, then if you apply the full factorial design, the number of readings which are to be recorded are shown here. How we get this column? It is basically the level to the power factor. So 2 to the power 3 becomes 8. 2 to the power 7 becomes 128. So if you can go on increasing the number of factors, your required number of observation which must be taken goes on increasing exponentially. So if I compare the last row, if I have 13 factors and if I go for full factorial experiment, I have to I have to collect the data, or I have to conduct the experiment this many times. So it is 15,94,323. But if we can compare it to Taguchi's experiment, that is by using orthogonal arrays. So for 13 factors and 3 levels, instead of this much readings, I can only take 27 readings, and the beauty is I will get the similar results. So this is the basic significance of using the orthogonal array for conduction and analysis of engineering experiments. Now, as I said, designing the orthogonal array every time is difficult, and this is the process which can be standardized. So rather than designing the array, some standard arrays are available. Now you have to just select the best array which is suited to your requirements. So how to select it? Number one is through linear graph, and number two is through Taguchi tables directly. So about Taguchi tables, you will find the link in the description, and you can download the PDF of Taguchi's table from the link in description. So by one simple example which is adapted from the book of Applied Design of Experiments in Taguchi Method by Krishnaya Sabuddin. This is the example which is adapted from there. So by referring to this example, we can perfectly understand the process of selection of orthogonal array. So what is the example? Consider an experiment with 4 factors. So let's say this is the engineering experiment which involve 4 factors, each at 2 levels. So what is the level of every experiment? It is 2. And apart from these 4 factors, there are 3 interactions, as you can see. So factor A is interacting with factor B, factor A is again interacting with factor D, and factor B is also interacting with factor D. So apart from 4 main factors, there are 3 interactions. So this basically shows the requirement of my experiment. Now how to select the particular orthogonal array which is best suited for this requirement. So step number one is to draw the DOF table. Basically, we will find out the degrees of freedom for every factor, every interaction, and the degree of freedom for my complete array. So the basic formula, the easiest formula for finding the degree of freedom is for individual factor, it is level minus 1. So your factor, as it is given in the requirement, the level of every factor is 2. So how to find the degree of freedom of that factor? It is 2 minus 1. So for all the 4 factors, my degree of freedom is 1. Then how to find the degree of freedom for interaction? Again, it is the multiplication of individual degrees of freedom. So interaction is AB. So degree of freedom of A into degree of freedom of B. So it is 1 into 1 eventually becomes 1. And whatever the number of factors and number of interaction are there, okay, the addition of that degree of freedom will give us the total degree of freedom of my orthogonal array. So by this step we can see that the degree of freedom which is required is 7. Now step number 2 is levels of factor and select OA. So how to select it? There are 2 conditions. Number 1 condition is DOF of OA should be greater than DOF required. Again, I will go back to this slide. What is the DOF required? It is 7. So what should be the DOF of my OA? It should be greater than 7. And number 2 is possible number of interaction in OA is greater than the interactions required. So how many interactions are required? 3 interactions are required. So whatever the array I will select, it must have provision to incorporate 3 interactions. Now how to select it? So refer the Taguchi table in annexure. Now just give me a minute, I will go to that table. Yes, these are table. So in this table, if I go to linear graphs, then some standard linear graphs are given here. So how to select it? So number one, can we select the L4 array? This is the graph, linear graph for L4 array. So what it is showing me, in this linear graph, the dotted points are factors and the line joining the dotted points are interaction. So if I see the linear graph for L4, it has only the provision for two factors and one interaction. And how many interaction is needed? What is our requirement? Our requirement is three interactions and degree of freedom greater than 7. So yes, the L8 array can give me three interactions. I will check it. How many factors are there? See, point number 1, 2, 3, and 4. And how many interaction? So number of lines are 1, 2, and 3. Similarly, 1, 2, 3, 4, 4 factors and 3 lines are also here. So I have two options for selection of my orthogonal array, and I have to find which option I will go for. Coming back to this slide, so we can select L8 array, but L8 array has two options, option number A and option number B. Okay, so I have to select either A or B. Now I will find which is best suited. So I will see what are the required interactions here in my research problem. The interaction I need is AB, AD, and BD. So this is the interaction I can need. So AB, AD, and BD. Now this is not possible here because if I keep the factor A in place of 1, I keep B, C, and D here, then I will get AD, AB, but I will not get BD. So the option number B is not possible when I need these three interactions. This thing will again get clear in the next slide when I will match this requirement with this option available. So how to do this? So step number 5 is superimposition of linear graph. So as I said, this option is not working for us. This is going to work for us. So we will superimpose this requirement into this available standard graph. Now how to do this? So this is the superimposition. These interactions are required by me and this was the option available. I superimposed this graph on this graph and got this. So in place of 2 I replaced by A, in place of 4 I replaced by D, in place of 1 I replaced by B, and keeping the C factor alone at 7 because it is not interacting with anyone. So this is the perfect superimposition of this requirement into this standard graph. So am I getting the required interaction? Yes. So A is interacting with B, so 3 becomes AB. B is interacting with D, so 5 becomes BD. And A is interacting with D, so 6 becomes AD. This superimposition of the required graph on the standard graph will give me the numbers along with factors and interaction. So what are these numbers for? 1, 2, 3, 4, 5, 6, 7. These are nothing but the column numbers in my format of OA, as you can see. So what array I selected? See here, I selected L8 array. L8 array means that array will have 8 rows and 7 columns. So as we can see, this is the format of orthogonal array, and these column numbers, which factor or which interaction is to be assigned to which column, that I will get from this superimposition graph. So on column number 1 I have to assign factor B, column number 2 factor A, column number 3 interaction AB, column number 4 factor D, column number 5 interaction BD, column number 6 interaction AD, and column number 7 factor C. So I will assign all the factors in the column. Now these readings are again, it will be blank because these are the level readings. So how many level I have for every factor in interaction? The level is 2. So this is populated again by using the tables. So in this table appendix B, standard L8 array, it will give you the readings which are to be filled in the matrix. So matrix is of 8 rows and 7 columns. These are the readings which you can get, standard readings which you can put in your orthogonal array. What are the two extra columns? It is basically the response column. Generally, we do not count response column in our orthogonal array. So these columns are there, but they are not they are not the part of L8 array. So how many columns are there? Two columns for response Y. So Y is my output, and why two columns? The thing which we discussed in the first slide. So there are two replications. Why the replications are used? To ensure that my reading is not faulty. It is not a mistake. So this is step number 6. We assign all the factors and interaction in finalized array. And step number 7. So the structure of OA experiment does not involve the interaction. So just what we did from this array, we deleted the columns of interaction, that is column number 3, 5 and 6. So it becomes our standard experiment. So this is not standard orthogonal array, but it is the standard orthogonal array experiment. So we have just hide the columns of interaction. So in this way, you can select a perfect orthogonal array for your requirement about your experimentation, and in this way you can design the OA experiment. Now this is the first step of Taguchi's experimentation. Once this OA experiment is constituted, or what you can say, you have prepared the orthogonal array for your experimentation, then you can proceed with the conduction of experiment. You record the readings, you fill up the readings in this OA experiment, and then this complete OA table is ready for statistical analysis, which will provide you the best results for your experiment. So thank you. I hope you understood the topic. The comment box is open for any kind of queries. Thank you. Thank you so much.